right, hello, welcome to lesson 1.5, 8.5, subtracting rational numbers. All right, in this lesson, you're going to be able to explain how to model rational number subtraction on a number line. You're going to be able to find differences of rational numbers by reasoning or thinking about their absolute value. So we're going to tie it back to what we did with integers and both subtracting them and then really turning them back into addition problems and thinking about those absolute values. And then we're going to find the differences between numbers on a number line. All right, so a couple things to keep in mind. We're going to apply the same rules as subtracting integers, which really means we turn our subtraction problems into addition problems and add the opposite. And then apply all those addition rules. Fractions need to have common denominators in order to subtract or add, right? And decimals have to have decimal points lined up in order to subtract or add them. A couple other things when we're working on the number line. Remember, if we're dealing with adding a positive number, we're using blue and we're moving to the right. And if we are dealing with negative numbers or adding a negative number, we're using red and moving to the left. So let's dive in and look at number lines to help us find the difference. Okay, 1/4 minus -3/4. Well, first thing we need to do, turn it into our addition problem. So it's going to become 1/4 plus 3/4. We keep the first term, change subtraction to addition, and make -3/4 positive 3/4. We write its opposite. All right, now we're going to draw this out on the number line. Now, 1/4 is positive, so we're going to start at 0, and I'm going to move right to 1/4. And you notice I broke up my number line into fourths here, 4 little sections between 0 and 1. Then 3/4, I'm going to go from 1/4, I'm going to go 3 more fourths. 1, 2, 3/4 more. Where did I end up? Well, look at that. I ended up at 1. And because we have common denominators, we can see what's 1 plus 3? It's 4. 4 over 4 is 1. So there we go. There's our answer. Plus, we added 2 positive numbers. They have the same sign. We add them up, and the answer stays positive because they're both positive. Now, let's take a look at this one. It's got decimals. Dun, dun, dun. Really, it's not that bad. 1.4 minus 2.6. Let's make it an addition problem. So we're going to have 1.4 plus -2.6. Keep, change, opposite. Keep the first term, change subtraction to addition, write the opposite. So we go to -2.6. Start out with a positive 1.4. Means I'm at 0, and I have to go at 1.4 spots. Well, all these little marks are tenths, because there's 10 little sections and I'm working in tenths, so that seemed to be reasonable. So I'm going to go from 0 out to 1.4. Here's 1, and then I'm going to go 0.1, 0.2, 0.3, 0.4. There we go. So there's 1.4. But now I'm adding -2.6, which means I have to go back left, grab my handy dandy red marker. There we go. And I'm going to go from 1.4, and I'm going to go back left to 2.6 spots. I'm just going to put in 1.4 there so we know where we're at. All right, now I go back. Let's see here. I can go back. Let's see, going back. Well, let's see here. That gets me going back 0.4. So remember, we've done 0.4. Now we're going to go back 1, 2. We've gone 2.4. We got to get to 2.6, so we got to go 2 more tenths. Boom, boom. Right there. And where did we end up? Well, that looks like -1.2, which I'm going to write in, and then we'll write as the answer. Just got to find the right color marker. There we go. So our answer is -1.2. All right, let's take a look at a few examples here finding the difference. Let's just apply our rules. Okay, so we have -8 2/3 minus 6 and 1/6. We need to turn this into an addition problem. So let's do that. Keep, change, opposite. So -8 2/3 plus 6 and 1. Forgot one thing. Eraser. Plus -6 and 1/6. Go. All right, now we have mixed numbers. Let's turn them into improper fractions. Remember, we multiply the denominator times the whole number and add it to the numerator. So keep our negative sign. 8 times 3 is 24, plus 2 is 26. So negative 26 over 3 plus negative 6 times 6 is 36, plus 1 is 37. All right, now we said earlier, fractions, you have to have common denominators. Well, what can I do? I can turn a 3 into a 6. I can multiply it by 2 over 2. That's what I'm going to do. And now I have negative 52 over 6 plus negative 37 over 6. Am I adding same signs or opposite signs? Right, I'm adding same signs. So I add their absolute values. 52 over 6 plus 37 over 6. Denominator is going to be 6. 52 plus 37, that's going to be 89. And you can leave it as an improper fraction. Reduce it if you can, but you can leave it as that. Now the question is it going to be positive or negative? It'll be negative, that's right, because I added two negative numbers. So my answer is negative 89 over 6. All right, let's step over here. 2 2/5 minus 6/5. Look at 6/5 already an improper fraction. Let's just make 2 2/5 join it. 5 times 2 plus 2. 5 times 2 is 10 plus 2 is 12. So I have 12 over 5 minus 6 over 5. Now are you looking at that going, I have a common denominator and I can just do 12 minus 6. You can. It's fine. You're saying, I know how to do that. And it's 6 over 5 and it's going to stay positive. But the question is, do you know why? So we know the answer is going to be 6 over 5 and that's fine. But let's just look at if we did keep change opposite, what it would be. 12 over 5 plus negative 6 over 5. Different signs, what do? We subtract their absolute values, which is what we just did. And then it stays positive because in our addition problem, the larger absolute value was positive to start with. That's why it works. But if you see right away, I can just do this problem, just do it. That's fine, okay? Now let's shift gears a little bit and let's look at some decimals. Remember decimals, we have to line up our decimal points, all that good stuff as we work. Let's rewrite in this addition problem. So we got negative 12.55 plus 23.8. Keep change addition to subtraction to addition, and the opposite of negative 23.8 is positive 23.8. But you notice we're not adding numbers with the same sign. So what do? Try to subtract their absolute values. Now remember, I like to stack these. So let's do that. Bigger absolute value on top. 23.8 minus 12.55. Notice I've lined up all my decimal points on my place values. What do I have to put there to hold my place? A 0. Now I subtract. That becomes a 10 because I borrowed. 10 minus 5 is 5. 7 minus 5 is 2. Bring down the decimal point. 3 minus 2 is 1. 2 minus 1 is 1. Now I have 11.25. Positive or negative? I'll go back and look at the addition problem. The larger absolute value was positive, so our answer is 11.25. Okay. Over here we have negative 3.75 minus 0.96. Rewrite as an addition problem. You got it. Negative 3.75 plus negative 0.96. Keep the first term, change subtraction to addition, so we're adding the opposite. Opposite of positive 0.96, negative 0.96. We're adding numbers with the same sign. Woohoo! That means we just add their absolute values and keep the same sign on the answer. But let's turn and stack everything up so all of our decimal points line up and all of our places do. Go. And add 5 plus 6 is 11, carry the 1. 7 plus 9 is 16, plus 1 is 17. Carry the 1, bring down the decimal point. 3 plus 1 is 4. And why is it negative? That's right, signs were negative. So we have negative 4.71. Okay, now we're going to take this another step and we're going to evaluate these problems. But you see there's multiple steps. And remember, if we turn these all into addition problems, we can use properties like the commutative property or the associative property to help us solve. Because we kind of know, oh, certain things go together, or wouldn't it be nice if these went in a certain order or something like that. So let's start here. Let's rewrite this as an addition problem. 6 minus 8.5 minus negative 2 3/4. Now in this case, we're going to keep change opposite, change opposite. So we always keep the first term and we change opposite everything anywhere else we see subtraction. Okay? 6 plus negative 8.5 plus positive 2 3/4. Subtraction became addition, we had the opposite. Positive went to negative. Here, subtraction became addition, negative went to positive. Now, let's write these as improper fractions. Alrighty, so 6 is 6 over 1 plus negative, not 8.5. 8 times 2 is 16 plus 1 is 17, negative 17 over 2 plus 4 times 2 is 8 plus 3 is 11, 11 over 4. All right, now we might look at this and say, okay, we need a common denominator. I hear you saying it's 4. Good call. Let's make them 4s. So for 6 over 1, multiply by 4 over 4. For 17 over 2, negative 17 over 2, we're multiplying by 2 over 2, and nothing to 11 over 4. So we've got 24 over 4 plus negative 34 over 4 plus 11 over 4. Now, are you saying, maybe I want to rewrite this, put this in a different order? Like maybe I want to add my two positives first because I know how to do that? Well, let's do that then. The commutative property lets us do that. Because it's all addition, we can move things around however we want. So we're going to use the commutative property here. All right, now let's add. Our denominator is the same, so let's go. 24 plus 11, 35, right? All right, so now we've got 35 over 4 plus negative 34 over 4. Subtract the absolute values because we're adding numbers with different signs. 35 over 4 minus 34 over 4 is 1/4, right? And is going to be positive or negative? Well, let's look at the addition problem. Bigger absolute value is positive, so our answer stays positive, 1/4. So this whole thing turns into 1/4 as our answer. That's not too bad. All right, now let's come over here. Let's look at some decimals. Once again, anytime we see subtraction, we're going to add the opposite. So first term always stays there. Subtraction becomes addition, negative 3.3 plus 1.2 plus 4.3. Okay, let's see. In your brain, is anything going, ooh, some stuff goes together. For me, I see a 7.8 and a 1.2, and I say, ooh, those go together. So I can move them and group them if I want, but I can just move them for now. 7.8 plus 1.2. I'm also going to move the 4.3, because why not add everything and then deal with the negative, right? So the commutative property lets us rearrange everything. And once again, we really want to put these two together first because I'm just going to start the process over here. I like to stack my decimals. 7.2 plus 7.8 plus 1.2. Look at that. 0, 1, 8, 9. Oh, well, that's nice. So I've got 9.0 plus 4.3 plus negative 3.3. Okay, let's keep going. All right, 9.0 plus 4.3. 3 is there, bring down the decimal point, 13.3. 13.3 plus negative 3.3. Okay, subtract, right? We subtract our absolute values because we're adding numbers with two different signs. Make sure your decimal points line up, and therefore all the numbers with it, 0, 0, 10, and it stays positive. You can just say 10 and say 10.0 because our bigger absolute value was positive to begin with. Now maybe you saw something here and said, oh, 4.3 and negative 3.3. That'd be 1. And then I'd have to add 9 and 1. Yes, that's another way you could think about it. Totally fine. It's all what your brain sees. And everybody's brain sees things a little bit differently. All right, so now we're going to find the difference between two numbers on a number line. And we're going to figure out what that distance is. Remember, distances on a number line really are absolute values because they're always positive. So the distance between two numbers on a number line is the absolute value of the differences of the numbers. Which means you take the two numbers, you subtract them, and take the absolute value of that answer. And it doesn't actually matter the order. You can do the left number minus the right number, so P minus Q, take its absolute value, or Q minus P. Doesn't make a difference, okay? So if you see it and go, oh, I can do a bigger minus smaller and that really makes sense in my head, great, do that. If you just want to work left to right, first number, second number, perfect, it doesn't matter. In fact, we'll solve both ways, I think, here. All right, let's look at the first one. 3 1/4 and 2 1/4. All right, well, we're going to take the absolute value, and we're going to do the absolute value part at the very end, okay? Because I just don't want to throw more lines in the middle of the problem that accidentally look like ones and confuse us. So let's start and turn these into, first we're going to do subtraction problem. Negative 3 1/4 minus 2 1/4. Here I'm going left to right, okay? Make them improper fractions, right? So we have negative 13/4 minus 9/4. Keep change opposite. Negative 13/4 plus negative 9/4. Adding numbers with the same sign. We already have our common denominators. Yay! So we add our absolute values. 13/4 plus 9/4 is 22/4. But it's negative because those were negative. Oops, I'm just going to write that over here. And then at the end, we take the absolute value and we say 22/4, which is equal to, well, here. Before we do that, we're going to go back and we're going to reduce our fraction because why not? Divide by 2/2, so you got 11/2. But it's negative 11/2, right? But we take that absolute value at the end. We say it's 11/2 for the distance. Or, how many groups of 2 are there in 11? There's 5 with 1 left over. So the distance between negative 3 1/4 and 2 1/4 is 5.5 units. 3 1/4 on one side is 0, 2 1/4 on the other side is 0. We can see that on a number line. Okay, I'll just show you real quick and then I'm going to erase. So negative 3 1/4 is over here. There's 0, there's 2 1/4. So we're putting this distance and that distance together. 3 plus 2 is 5. So a distance of 3 1/4, distance of 2 1/4. 3 plus 2 is 5. 1/4 plus 1/4 is 2/4 or 1/2. 5.5. Now, if you said, I want to do bigger minus smaller. Okay, well then let's solve it that way. I'm just going to do it in a different color so it stands out a little bit. All right, 2 1/4 minus negative 3 1/4. All right, right. Let's make them improper fractions. So we've got 9/4 minus negative 13/4. Keep change opposite. Add the opposite. So 9/4 plus 13/4. Hey, we're adding numbers with the same sign. And they're positive. We know how to do those. Let's just do it. That's 22/4, which we can divide by 2/2, 11/2. We take the absolute value because we're supposed to. Remember, absolute value keeps it positive, but that's equal to 5.5. Either way, we get the same answer. Do I care which way you do it? No. Whichever one makes more sense to you. Some people they just like going, it's left, right, boom, subtract. I say, well, I see the bigger number. I know when I want to find the range or the difference between things, I want to do bigger minus smaller. It's all how your brain thinks. Okay, now let's look at this with decimals. Negative 2.4 and 6.7. What's the difference between them? Well, let's do it the first way. 2.4 minus 6.7. First minus second. We're going to do the absolute value thing at the end again. So we do, keep change opposite, negative 2.4 plus negative 6.7. Adding numbers with the same sign. Stack them up. Add them up. 4 plus 7 is 11. Carry the 1, bring down the decimal point. 1 plus 2 is 3 plus 6 is 9. But our answer needs to be negative because both numbers we were adding were negative. So negative 9.1. Take its absolute value. That's 9.1. So it's a difference of 9.1. If we looked at that on a number line, we'd see that. So if here's 0, there's negative 2.4. Here's 6.7. This distance is 2.4. This distance is 6.7. Put the two together, 9.1. All right. But if you said, no, I really want to do bigger minus smaller. Okie dokie. Let's do that. No problem. Bigger minus smaller. 6.7 minus negative 2.4. Keep change opposite. Keep 6.7 plus 2.4. Hey, look at that. I know how to do that. I'm adding two positive numbers. I'm going to stack them up. Add them up. We just did this. 9.1. It stays positive this time because we're adding positive numbers. But we take the absolute value of 9.1, which is 9.1. See, either way, we got the same answer. So, find the difference between the two numbers, take the absolute value of that answer, and that gives you the distance between two numbers on a number line. All right, now lastly, we want to look at a way that we can use differences of rational numbers. So this is a little scale or graph on a number line of high and low temperatures for someplace. We have 18.7 degrees Fahrenheit, and that's going to be our high, and our low is negative 5.4 degrees Fahrenheit. Must be winter, it's kind of cold. Now, we're asked to find and interpret the distance between the points. So find means actually calculate it, and then what does that number mean is the interpret. So find is calculate. Interpret means what does this mean? All right, so we can find that. We find the difference between the two numbers, right? And is it going to be positive or negative? So it's going to be positive because we're going to find the absolute value. So let's do 18.7 minus negative 5.4. Okay, we'll do the absolute value again at the end. Keep change opposite. All right, could we have done negative 5.4 minus 18.7? Absolutely. Pick one way. Here it makes sense. Top, bottom. Bigger, smaller. All right, I'm adding two positive numbers. I'm just going to turn and stack them and add them up. Make sure your decimal points are lined up. 7 plus 4 is 11. Had a lot of those today. 1 plus 8 is 9, plus 5 is 14. Carry the 1, 24. And it's going to stay positive. It's a distance, but we're going to confirm that by officially taking the absolute value and saying 24.1 degrees. That's the distance between the points. What does this mean? So that's the calculate. There is a 24.1 degree difference between the high and low temperature. It doesn't have to be a deep, profound statement. What does it mean is simply just putting a sentence around the number that you calculated usually. Okay, so we have figured out how we can subtract rational numbers using a number line, using absolute values, so going back to some of our old rules and seeing how they tied in with subtracting integers and really turned back into addition problems. Looked at finding a distance on a number line and some ways to apply it. Thanks for watching.